Lesson 2.5, Multiplying Decimals. In this lesson, you will learn to multiply decimals. Key idea, multiplying decimals by whole numbers. Multiply as you would with whole numbers, then count the number of decimal places in the decimal factor. The product has the same number of decimal places. In other words, you look at the two factors that you're multiplying. In this case, 13.91 has a decimal. After you do your multiplication and get your product, you go back to the factor and look at how many places there are to the right of the decimal. In this case, there are 2 decimal places. Your product must also have 2 decimal places. So you move it over 2, and 97.37 has 0.37, 2 decimal places to the right of the decimal. In the second example, 6.218 times 4, this is your decimal factor, the factor that has a decimal in it. It has 3 numbers to the right of the decimal. So your product, your answer, must also have 3 decimal places, 24.872. Let's try example 1, multiplying decimals and whole numbers. Find 6 times 3.91. So I'll record 3.91 times 6. First step is to multiply as usual, so 6 times 1 is 6. 6 times 9 is 54. Record the 4 and regroup the 5. 6 times 3 is 18, plus 5 would be 23. And then my last step is to place my decimal. I go back and see that this is the decimal factor, the factor that has a decimal. There are 2 places after the decimal. I need to have 2 places after the decimal in my answer, so it goes here at 23.46. I can do a sanity check on that to make sure that seems like a reasonable answer by saying that this is very close to 6 times 4. 3.91 is close to 4. So my answer should be close to 24 then. 6 times 4 is 24. So that could be my estimate there, about 24. 23.46 is close to approximately 24. So my answer is reasonable. Let's try B, 3 times 0.016. You notice that I am recording the number with the most digits first. It's not the largest number, but it's the number with the most digits. That just makes my multiplication easier. First step is to multiply as I would with whole numbers. 3 times 6 is 18. Record my 8, regroup the 1. 3 times 1 is 3, plus 1 is 4. 3 times 0 is 0. 3 times 0 is 0. I go back and look at my decimal factor, the number that has the decimal in it, and I see that there are 1, 2, 3 place values now to the right of the decimal. So I need to move the decimal 3 places here, and it would go in right there, 0.048. Again, doing a sanity check, if I went back to estimate this original problem, my estimate would say that 3 is 3, and 0.016, that is 16 thousandths. That is very close to 0. This whole number closest to it would be 0. And 3 times 0 is 0. So my answer should be close to 0. 0.048 is 48 thousandths. That is also close to 0. So my answer is reasonable. Example 2, use mental math. How high is a stack of 100 dimes? The diagram shows us that 1 dime is 1.35 millimeters high. What we need to figure out is how high would that stack be if we put 100 dimes one on top of the other. They're asking us to use mental math, so let's think about what we know about multiplying by powers of 10. Here we're multiplying by 100. Remember, when we multiply by a power of 10, we count the zeros. There are 2 in 100. So we can move the decimal point 2 places to the right and get our answer. We had 1.35. Move our decimal 2 places to the right, and we'd have 135. and the units are millimeters, abbreviated mm. That would be mental math. Just realizing that we have a power of 10 here, 2 zeros, move the decimal place 2 zeros. Let's calculate to confirm. 1.35 times 100. If we multiplied this out, of course, 0 times 5, 0 times 3, 0 times 1 are all zeros. Again, for the tens place, those would all be zeros. And then in the 1 times 5 would be 5, 1 times 3, and 1 times 1. Adding those columns together, 0, 0, 5, 3, 1. And then let's look at the place value. We have 2 places on this factor. This factor doesn't have any, so moving 2 places, we would be at 135.00. And again, you don't have to have the decimal there when we have zeros remaining and only zeros remaining. So our answers would match up, 135 millimeters. But the mental math was much quicker. So whenever you're multiplying by a power of 10, think about doing it that way. Key idea, multiplying decimals by decimals. Multiply as you would with whole numbers, then add the number of decimal places in the factors. The sum is the number of decimal places in the product. For example, 4.716 times 0.2, you multiply as you normally would. Then you go back and now both numbers, both factors, have decimal places in it. So you count the number of decimal places in the first factor, and there are 3. Count the number of decimal places in the second factor, there is 1. You add those two together and there are 4 decimal places then between the two factors together. So in your answer you move your decimal 4 decimal places. Let's try example 3, multiplying decimals. Problem A, 4.8 times 7.2. Multiply first as usual. 2 times 8 is 16. 2 times 4 is 8 plus 1 is 9. 7 times 8 is 56. 7 times 4 is 28 plus 5 is 33. Adding those two sets together, 6 plus 0 is 6, 9 plus 6 is 15, 3 plus 1 is 4, and there is nothing to add to the 3. So that's multiplying as usual. Then I go back and check my decimal places. I have 1 decimal place here, and I have 1 decimal place here. Adding those together would give me 2 decimal places. So I'm going to move my answer 2 decimal places. And my answer would be 34.56. Does that sound reasonable? I could say that 4.8 is close to 5, and 7.2 is close to 7. So estimating, my answer should be close to 35. 34.56 is close to 35, so that is a reasonable answer. Let's look at question B. Multiply 3.1 times 0.05. Again, I like to put the number with the most digits on top. You can do it the other way. It doesn't really matter. That's just my preference. First step, multiply as usual. 1 times 5 is 5. 1 times 0 is 0, and 1 times 0 is 0. 3 times 5 is 15. 3 times 0 is 0 plus 1 is 1, and 3 times 0 is 0. Adding those together now, 5 plus 0 is 5. 0 plus 5 is 5. 1 plus 0 is 1, and the 0 has nothing to be added to it. Now going back and looking the decimal places of my factors. This factor has 2 decimal places. This factor has 1 decimal place. I'm just counting over like this. 1, 2, 1. So I add those together, 3 decimal places I need to move my answer. 1, 2, 3. So my decimal would go here at 0.155. Is that a reasonable answer? Well, looking back at my original problem, 3.1 is close to 3. And 0.05 would be 5/100ths. That is a very small number, closest to 0. 3 times 0 is 0. And comparing that to my answer of 0.155, that's 155 out of 1,000. That is also very close to 0, so my answer is reasonable. Example 4, evaluating an expression. What is the value of 2.44 times the quantity 4.5 minus 3.175? Whenever I'm looking at evaluating an expression, I need to think about, please excuse my dear Aunt Sally, P being parentheses and I see some right here, so that's going to be the first step in this solving of this expression. 4.5 minus 3.175. In this case, I can't say I want to put the number with the most digits on top because in subtraction we know that the order matters, and this says I have to take 4.5 minus 3.175. So what do I do about these empty places here? I can just put zeros in there. It doesn't change the value of that number. 0 minus 5, I can't do that, so I have to come all the way over here to the tenths and break that 5/10ths down into 4/10ths and transfer over those into my hundredths. 1/10 would be 10/100ths. Now I can take one of those hundredths away and break that down into 10,000ths. Now I can do my subtraction. 10 minus 5 is 5. 9 minus 7 is 2. 4 minus 1 is 3. And 4 minus 3 is 1. And then I need to always remember that in subtraction or addition, I bring my decimals straight down. So it would go right here, and this part of the expression now would be 1.325. So my expression now would look like this: 2.44 times 1.325. I would never do multiplication in a horizontal state like that, so I'm going to rewrite them, and now I'm going to think, okay, I'm multiplying. The order doesn't matter. I'm going to write the number with the most digits first. For me, that is easiest to multiply. 1.325 times 2.44. First step in multiplying decimals is to multiply as usual. 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. 4 times 3 is 12, plus 1 more is 13. 4 times 1 is 4, plus 1 is 5. Next row is 4 again, so I know I'm going to get the same numbers there. Multiplying 4 by the same set of numbers. And then 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, and 2 times 1 is 2. Adding those columns, 5 plus 5 plus 3 is 13. 6 plus 5 plus 1 is 12, and 2 plus 1 is 3. Now I get to the part where I need to count the decimal places. Counting the decimal places in my factors first, I see there are 1, 2, 3, and here there's 1, 2. So 5 decimal places I need to move my decimal. 1, 2, 3, 4, 5. And my answer becomes 3.23300. I don't need those zeros on there, but that would be the solution to the expression 2.44 times 4.5 minus 3.175.